So let's do the following examples. Our instruction is to simplify the following expressions, and we do so by factorizing, cancelling, and then simplifying. So let's have a look. In our numerator, we have a binomial with a common factor of 2. So what remains is x minus 1 all over 2, all over 2, all over 2, and therefore we end up with x minus 1. So that is simplified. We look at the next one, and I have ticks over here because we have a perfect square, subtraction, and another perfect square, which means that we are working with a difference of two squares. So we focus on the numerator and we go ahead and simplify that. Okay, so we go with our two sets of brackets, plus sign, minus sign. So we got x plus 9 and x minus 9. Now when we go to the denominator, I'm hoping that it's obvious that this is a trinomial. There's my x squared term, there's my x term, and there's my constant. So the factors of 18 would be 1 and 18. We got 2 and 9. And I won't go any further because it appears as though I have found the pair that works. So in order for us to produce a positive 7 using 2 and 9, we need to go ahead and say minus 2 plus 9 to get the plus 7 for the middle term. And so this factorized is x minus 2 and x plus 9. At this point, we factorized completely, and now we can cancel, right? So we cancel top with bottom, bottom with top, right? Of course, the x minus 9 and the x minus 2 cannot cancel, and so your final answer will be x minus 9 all over x minus 2. Okay, so if you look at this final product here, it looks a lot better than what we started out with, and so this appears to be a simplified version of what we had initially. Moving right along, again we factorize, then we cancel, and then we simplify. If we look at example 3, in our numerator we have two terms, which might lead you to think that this is a difference of two squares, but it is not, because 27 is not a perfect square, and neither is x exponent 3. So this could possibly be a difference of cubes. We just need to make sure that all our boxes are ticked. So I got a cube, subtraction, and another cube number. And so this is a difference of cubes. If it was a sum of cubes, we would call it socks, but it's a difference of cubes, so we call it docks. So now I have the rules in blue at the bottom of the screen for us, and so we go ahead and we factorize that numerator. So we have our two sets of brackets. In the first bracket we got the cube root of x cubed, which is x, minus the cube root of 27, which is 3. And then for our first term in the second bracket, we say x squared. Then we multiply the two values in the bracket, which is 3x, and we give it the opposite sign. Okay, and then finally we square the 3, which gives us 9. Now we go ahead and we focus on this denominator, right? This looks like a trinomial, but I'm also noticing that common factor, and you always do common factor first. So we go ahead and we take out our common factor of 2, and we remain with the factor x squared plus 3x plus 9. And now this is a little exciting because now I see that this trinomial can cancel straight away, and I don't have to worry about factorizing it, because now I have my simplified answer, that is x minus 3 over 2. And there we have it. Easy. This complicated fraction that we started off with simplifies down to this beautiful fraction that has 1x minus 3 all over 2, and it will yield the same answer we would have gotten should we have substituted the x value up there.